Can you see the slide movement, Sharma? Can you see the slide movement, students? Hello?
Yes, ma'am.
Okay. So in the last class, we have started with the operators. Okay. And you already know there are a variety of operators that are found. Arithmetic operator, relational operator, logical operator, bitwise assignment operator, increment, decrement operator, and conditional operator. Okay. And we already know what is binary operator and unary operator. Then we went for the arithmetic and relational and logical operator there. Right? So today we'll talk something related to the bitwise operator. Okay. So we'll talk something related to bitwise operator. So what is this bitwise operator is talking about? So if you go ahead with this bitwise, okay, so it's a little different from what you have studied for the logical operator there. So because you have used AND operator also, OR operator also there, okay, it is similar to that of the same thing, but here we are able to do that on a single bits. Okay, what is the meaning of single bit? Because you have given with, let me take. Okay. So if you go ahead with this, so here you have something called as, if I take any number, maybe let me take it as number 4. Okay, so this number I am converting this into binary number. Okay, even system does the same thing. So this is converted into binary number before we carry out any bitwise operator on it. Carry out any bitwise operation on it. Okay. So how do I convert this? It purely depends on how much, what is the size of this. Okay, so if I take this is 4, so I'm able to write this as, because how do you write the decimal numbers? In the similar fashion, you should be able to write for this also. Okay, I'll try to write the same thing. So I'll write this as something like 100. So this corresponds to 4. Then how I have written, I'll write the same thing now. So 2 to the power 0 first power, second one is 2 to the power 1, then you have 2 to the power 2, 2 to the power 3, how you people work for the decimal numbers. 10 to the power 0, 10 to the power 1, so 10 to the power 2, so this is unit place, 10th place, 100th place, then 1000th place. Okay, similar to that, you have the position for the these binary numbers in the given number there. So I have written for. Now I'm just trying to convert that using this particular formula. So if I write 1 over here and other 2 are 0, and if you look at this, all other terms are 0. You go on expanding this, all other terms are 0 there. So if you look at this, this is 2 raised to 0, this is 0 term over here, and this is 2 raised to 1, so multiplied by 0, this is also 0 over here. So 2 to the power 2 is 4, 4 multiplied by 1 is yielding me what we call it as 4. So here if I write number over here, so if I write something like this, 100, so I'll say it is 100 because this 1 is placed inside the 10 to the power 2's position, that is 100th position. Okay, this is how in the similar fashion we are writing for the decimal, the binary number also. Okay, system also does the same thing and it will try to give you the binary number for that. Okay, is that okay, students? Hello? Hello? Hello?
Yes, ma'am.
Okay. So now I have 100 over here. Okay. So now I have another number. If I take it as 5, how do I write 5? So in the similar fashion, I'll try to write. So I'll be writing it as 101. It is 5 because this is 2 to the power 0. This is 2 to the power 1. This is 2 to the power 2. So 2 to the power 2 is 4. 4 into 1 is 4. So this is 0. So I'll be, if I add 0 also, I'm getting it as 4 itself. Then 2 to the power 0. Okay, multiplied by 1 is 1 now. Okay, because anything raised to 0 is always 1. 1 multiplied by 1 is 1. So 1 plus 4 is 5. So that's what I am getting over here. So now whenever I do the operation, so I am converting a given decimal number or hexadecimal number. You take any number that has to be converted into binary number before we proceed with. Okay, that's what the system is doing. So now because we are interested to work on the bits rather than the actual digits there. So now here these are the bits. 0, 0, 1 are the bits. 1, 0, 1 are the bits. So now what I am supposed to do, if I take here, let me write here 1 0 0 1 0 1. Okay, so now I am going to carry out the operation on the individual bits that I am going to pick out of the number there. So this is for, so in this I am taking the units place data. So this unit place data after picking, so I am going to carry out one or the other operation here. So I may carry out the AND operation, I may carry out the OR operation, I may carry out the XOR operation, may go ahead with the left shift, right shift, or a ones complement there. So here we are carrying out these operation on the bits rather than the whole number there. We are not considering the whole number, but we are converting that into binary, and on individual binary digits we are playing with these things. Is that clear, students? Is that clear, students?
Yes, ma'am.
Okay, so I'll take example for these things. Just remember this. Okay, so we are going to do the operations on the bits, not on the digits. Right? With this, let's go to the first operator. So first operator is AND, next operator is OR and XOR. I have given you the truth table for the same thing, and you already know about the truth table. If both are 0, if it is AND operator, what is your expectation for that?
False.
False, correct? No? It is 0. So 0 and 1. What is your expectation?
0.
Very good. Okay. So 1 and 0.
0.
0.
0.
Right? So 1 and 1. 1 and 1.
1.
1. Correct. You already know about this truth table. Okay. Or truth table is like this. 1 0 odd with 0. I am expecting it to be 0 there. 1 odd with 0. I am expecting it as 1. 0 odd with 1. I am expecting it as 1 itself. 1 odd with 1. I am expecting it as 1 itself. Okay, so you already know about these things. So XOR operation you already know. So if I take number something like this, if this is A and B, if it is 0 0 0 1 1 0 1 1, so operation XOR operation is A into B complement plus A complement B. This is the actual XOR operation. So how do I do? Okay, you already know A is 0 here, B is complement of this. So this is 1 complement of 0 is 1 here. Okay, so now this is 0 multiplied by 1 plus 1 is, A bar is 0 complement. This is 1 again
1.
multiplied by, this is 0. What is the answer you are expecting out of it? 0 into 1 plus
0.
1 into 0. 0.
0.
Is that clear? So what is the output for this 0 1?
1.
1. How do you say? You just expand this. How do you write this? This is similar to
0
A.
into 0.
This is 0. 1 complement of B is, so B is 1 here, right?
0.
So this is 0. Then add,
Zero.
these two will be multiplied here. Then again I have A bar B. Okay, so what is A bar? So A is 0. Bar of
1.
this is 1 multiplied
1.
by B is 1. So I'll write it as 1.
1.
So 0 into 0 plus 1 into 1. What is your expectation out of it?
1.
1. Correct, no? That's why I'm going to get this as 1. So this is how we got this as 1 here. So first thing is 0. So I wrote it as 0. Similarly, if you carry out whether the A is 1 or B is 1, so I am expecting the output as 1 there. Okay, so any one of both the terms are either 0 or 1, then that time the XOR operation always yields us 0 there. Is that clear, student?
Yes, ma'am.
Any doubt in the truth table, people can ask me, because you people have already know about this. I'm not digging too much about that, because electrons are electronic subject. You are studying the same thing. You have AND operator, operations. You have OR operations, XOR operation, and you are doing some simple experiments also on AND gate, OR gate, NOT gate, something like that. Okay, so on that basis, I am going ahead with these things. So any doubt regarding a truth table?
No, ma'am.
No. Okay. Let's take the number now. So I've taken the first number as something like A. A is equal to 9. So B is equal to 7. Okay, so now how many digits I have taken? Too many digits to display this. It is left to people because it purely depends on the system. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, it's a 2-byte number that I have displayed here. Okay, it purely depends on a compiler whether that number has to be, because we know that integer is of 2 bytes. Correct, no? I've given you the integer size also there. Have I given integer size there? I've given you the range, no? Have I given you the range for the integers there? In the second, I mean, maybe in the last to last class, I have discussed about that. Integers, characters, floating point value. I said integer is 2 bytes, floating point value is 4 bytes.
Yes, ma'am.
Yes, okay, here it is, that's why it is taking 2 bytes. So here it, also it is 2 bytes. So this is 2 byte, this is 2 byte. Okay. So now how do I mean confirm that these are the number what I have written here. Okay, so let's look into the same thing. This is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, and all other terms are 0. I'll not be worried about that. So let's look into this. Anything raised to 0 is always 1, 1 multiplied 1 is 1 itself. Okay, then this term has become 0 because it is multiplied with 0. This is also 0, so that's why I don't have any 2 to the power 2 term over here. But if you go ahead with 2 to the power 3 term here, so 2 to power 3 is how much?
8.
8. 8 into 1 is
8.
8. So I'm adding 8 with 1. What is your expectation out of it?
9.
9. Is it 9 here?
Yes, ma'am.
Yes. So whatever number I have written, is this right number?
Yes,
Is the
ma'am.
right number that I have written? Say something.
Yes, ma'am.
Okay, so now this is how we have to play with the numbers, binary numbers. Okay, so if you go ahead with the second concept here, so I wanted to check whether this is 7 or no. So again, I'll write 2 to the power 0, 2 to the power 1, 2 to the power 2 here, and these are all 0. Even though I take also, if I multiply that number with 0, I'm getting it as 0. I'll not be worried. So I'll take only these things. 2 to the power 2 is
4.
plus 2 to the power 1 is
2.
plus 2 to the power 0 is
1.
So I'm getting all these numbers because I am having 1 in all the terms. If any one of these term is 0, then that term is going to become 0 there. Is that clear?
Yes,
Is it clear? So instead of this, if I am having this term as 0 here, 1, 0, 1, then this term is going to become 0 there. So 4 plus 0 plus 1, it is yielding me 5 in that case. But here it is 1 here. So it is 4 plus 2 plus 1. What is the value?
7.
7. Is it the same 7 that you have taken here?
Yes, ma'am.
Yes. So I hope you are able to write the numbers. Okay. Anyhow, I think, okay, maybe you have a numbering system there, you may be able to write these things. Okay. Otherwise, whenever you are learning CO, so that time at least you'll be learning the representation of a numbers there. But this is how usually we go ahead with how you play with the binary, the decimal numbers. In the similar fashion, you can play with any different kind of numbers there. Maybe with hexadecimal numbers, maybe with the octal numbers, maybe with the the binary numbers. Okay, so that is how, it is true with all the numbering system. If you are thorough with the basic decimal number representation, and the same concept can be adopted for any of the numbering system. There is no doubt in that. Only the base is going to change. Okay, for decimal number, base is 10. For binary number, base is 2. For hexadecimal number, base is 16. For octal number, base is 8. Okay, so it takes some other numbering system also. So for everything, only the base is going to change. But otherwise, other concepts remain same. Is that clear?
Yes, ma'am.
Okay, so now, if you want to, people can play with, you can check it out. Okay, I'm just giving an example. Okay, so now, because I am interested to concentrate only on the AND OR operations. Okay, now here I am interested to do the AND operation, and you already know the truth table. According to that, we'll carry out the operation on the individual digits, individual bits there. Okay, this is the first bit. Okay, and I'm taking this bit. I'm going to do the AND operation on these two. 1 is ANDed with 1. What is your expectation?
1.
1. So are you getting it as 1?
Yes, ma'am.
Okay. So 0 ANDed with 1.
0.
0. 0 ANDed with 1.
0.
1 ANDed with 0.
0.
0.
0 ANDed with 0.
0.
0.
So all terms are 0 here. I have to expect these all terms are 0 there. There is no issue in that. Is that clear?
Yes, ma'am.
This is the output for the AND operation. Okay. So how do I write that? So I'll be writing AND A ANDed with B. Okay. And I'm going to store this inside X. If I check the value of X, okay, what is the X value that you got over here? A ANDed with B. What is this result? If I ask you convert this into decimal number, what is your answer for this? Anyone of you?
15, 0, 1.
15 zeros, you are not considered 15 zeros. You have to convert that into decimal number. Decimal number is having 1 or 2 digits, not more than that, because it is just a 2-byte
1.
number. Is it 1?
Yes, ma'am.
How do you get?
Yes, ma'am.
How do you get this as 1?
ANDed with
100 with? Now I am just asking you, you have this binary number. Okay, this is a binary number that you got after ANDing these two numbers, correct no? After ANDing you got
Yes,
this
ma'am.
number. I am asking you, what is the decimal equivalent of this binary number? This is 0000001. Okay, this is a number. I am asking you, what is the decimal equivalent of this binary number?
Power 0.
So it is having 2 to the power 0 and all other terms are 0 here. Correct? So 0 added with 2 to the power 0 into 1. So that is 2 to the power 1. 0 is always 1. Correct no? Anything raised to 0
Yes,
is
ma'am.
always 1. No? Okay, multiplied with 1. So what is your answer? So all terms are 0 here. I am added all zeros. I got it as 0 itself. 0 plus 1. What is your answer?
1.
1. So
1.
that's why it is 1 here. So decimal equivalent of this particular binary number is 1. Clear?
Yes,
Is this
ma'am.
clear? So that's why X value is 1 here. So this is 9. So this is what we call it as 7 here. So 9 is ANDed with 7. It is yielding me 1 there. So any doubts before I proceed, you people can ask me. If you have any doubts, please feel free to ask the questions. No doubts, we'll proceed with. Okay, then go ahead with the OR operation now. So again, I am taking the same two data. I am doing the OR operation. 1 OR with 1.
1.
1. 0 OR with 1.
1.
0 OR with 1.
1.
1 OR with 0.
1.
0 OR with 0.
0.
0 OR with 0.
0.
And for all other terms, it is 0 only. Correct? Is it okay?
Yes, ma'am.
Okay. Now, can you tell me what is the decimal equivalent of this number now?
2 raised to 0.
19.
How much?
2 raised to 0.
I am asking you, tell the
19.
decimal. Is it 19? Check it out.
15.
Very good. It is 15. It is 15. So this is 2 to the power 0. This is 2 to the power 1, 2 to the power 2, 2 to the power 3. This is 8. This is 4. This is 2. This is 1.
2.
15, no? 8 plus 4 plus 2 plus 1 is 15. So this is 15. Is it okay?
Yes, ma'am.
Okay, that's why I got this as 15 over here. So A, okay, A piped with B. A is 9, B is, what is that? B is 7. What is the answer in
7.
X? X is nothing but 15 that I'm going to get. Clear?
Yes, ma'am.
Okay. Next is XOR operation. Now you only tell me what is going to happen in the XOR operation. So these are the two numbers that we have taken there, and this is the final answer that we are expecting there. Okay, 1 second. 1 XORed with 1.
Zero.
Little louder.
Zero.
0. 0 XORed with 1.
One.
1.
One.
0
1.
XORed.
1.
1 XORed with 0.
One.
1.
1.
One.
0 XORed with 0.
0.
0.
So all other terms are 0 because all other terms are 0 here. Correct? Is it okay?
Yes, ma'am.
Is this okay? Now can you tell me what is the decimal equivalent of this now?
14.
14.
40. Is it 14?
14.
Because 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. This is 8 plus 4 plus 2. So 8 plus 4 is 12. Okay, 13, 14. So this term is not existing because it is multiplying with 0 here. So I'll get this as 0 there. So that's why I'm going to get this as 14. Is it okay?
Yes, ma'am.
Okay, so now A XOR. So XOR is this symbol. A, B, X is equal to this. So X, I got this as 14. A is 9, B is 7. Is this okay?
Yes, ma'am.
Yes, ma'am. So inside the computer, whenever you are using these operations with your C language there, so please remember for bitwise operation. I'll repeat my statement for bitwise operation. Okay, if you are carrying out AND bitwise operation, then you have to use 1 ampersand. Don't use double ampersand. Double ampersand is a logical operation. Double ampersand is logical operation. This is bitwise AND operation. Okay, single AND. This is single AND. It is not double AND. Am I clear with my statement?
Yes, ma'am.
Yes, ma'am.
Okay, so now this is again bitwise OR operation. So we have to use single pipe for it. Usually we'll write like this. So you have to write the single pipe. Okay, so don't use double pipe. Double pipe leads to a logical OR operation. So that must be used inside the condition. Okay, this can be used as a part of your expression. So this is usually used inside your conditional statements here, logical operations. Okay, whether this person is good or that person is good, you wanted to check. Okay, in that case, you will be using the logical operations. Here, you wanted to carry out some operations. Okay, you're subtracting, your multiplication, you are doing some operations. Here, you are doing on individual bits there. So that's why we call it as a bitwise operation. Right? So AND is one operation, another is OR operation. Next one you have XOR operation. Okay, for XOR operation, this is a symbol that is used. This symbol is called as cap symbol. Cap. Is that clear? This is pipe. Okay, this is ampersand. Ampersand, pipe, and cap. Clear? Say something. Understood?
Yes, ma'am.
Okay.
Yes, ma'am.
Right. Now we'll go ahead with the shift operations. Okay, so now shifting operation will be done on single data, so don't do it on multiple data. Okay, so now I have some data here. Okay, something like 9 that is given. So the same 9 I have taken here. Now I am going to do the shift operation. Okay, so this if I write like this, so this is talking about a left shift. So it is talking about a left shift. What I am going to shift towards the left side. Individual bits I am going to shift towards the left side. Okay, individual bits must be shifted towards the left side. Okay, so now how many times you have to shift, that is mentioned over here. If I write here 1, so I have to shift the contents of this particular A towards the left side by 1 bit. Instead of this, if you write it as 2, then I have to shift this towards the left side by 2 bits. That's what is the meaning of that. Clear? Is that clear?
Yes, ma'am.
Okay, so let's look into the same operation. So I'll show you the operation, how it is going to take place, right? Okay, so now I'm going to shift the contents of A by 1 bit towards the left side, because this is telling me to move towards the left side. Okay, A is 9. How do I do? So this is in the 2 raised to 0th position. This is 1, 2, okay, 2 raised to 3 and 4 and 5 and so on. And look at this. This is shifted towards this position. So 2 to the 0th position data is moved to 2 to the power 1th position. So this is shifted like this. This is shifted. So am I shifting it towards the left side? Say something.
Yes, ma'am.
Yes, this is what is the meaning of left shift. Clear? So this is discarded there because it is going to leave this particular value, and 0 has to be stuffed from the other side. So we are appending a 0 on the right hand side because nothing is there in this particular LSB bit. Okay, we have to stuff 0 here. So this is my new data. What is this data? Can you tell me the equivalent decimal number of this?
10.
10010. What is this number is? Any one of you?
34.
10.
Is it 34? Check it out. 2 to the power 0, 1, 2, 3, 4. So in 2 to the power 4 you have data, and 2 to the power 1 you have a data there. So this is 16, this is 2. How much is this?
18.
18.
18.
So this is 18. 18. Is that okay? Is that okay?
Yes, ma'am.
Yes. Okay. So usually what happens if you do, if you shift any data towards the left side, it is always, it does the multiplication by 2. So this is after doing left shift, you got this as 18. So what was your initial number? 9. 9 is multiplied by 2. What is your answer, your expectation? If 9 is multiplied
18.
by 2, are you getting it as 18?
18. Yes, ma'am.
Are you, yes? Okay. This is actually the truth behind the, the system that does. Okay. Because once you learn the organization, computer organization, there you will be knowing about all these things. Okay. So don't worry. So this is what is happening there. Okay. So left shift. Okay. By how many bits? 1 bit. So I already mentioned. So you can have any number of bits that can be shifted towards the left side or a right side there. So any doubt regarding a left shift there? Any problem regarding left shift? Speak, please.
No, ma'am.
Okay. Now we'll proceed with the right shift. Okay. So now, so if you go ahead with the right shift here, so what I'm going to do? So here we went for the left shift. Now we have to shift it towards the right side, right? So bitwise shift. So again, I'm having this kind of a data here. So look at the data. So this is 1010. So this is 2 to the power 3, 2 to the power 2, 2 to the power 1, 2 to the power 0. So this is 2 and this is 8. Okay, 8 plus 2 is 10. So I got this as 10 itself. That's fine. So I'm shifting this towards the right side by how many bits? 1 bit.
1 bit.
Very good. Okay, so I'll show you the same shifting. So this contains, this I call it as MSP, most significant bit. This is termed as least significant bit. So most significant bit will be now started shifting towards the right side. This bit is coming over here, this is 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 here, 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 and this has moved to this position. This has moved to this position. This has moved to this position. Now this one is out. And we are, MSB is free now, so we are stuffing 0 at the other side. Stuff. Or dump. Is it okay? Here we went for the left
Yes,
shift
ma'am.
like this. Okay, here we are moving towards the right, shifting towards the right side. Clear? Clear, student?
Yes, ma'am.
Okay, what is this data then?
5.
5. Is everybody is agreeing? Is it 5?
Yes, ma'am.
Yes.
Yes, ma'am.
Okay, so now, I have given 10 as a data and I am getting output as 5 there. It usually right shift divides that number by 2. Usually, okay, so not always. Okay, usually it does like that. Is that clear? So 10 by 2 is yielding me 5. I hope it is clear to everybody. Any doubts, you people can ask me. No doubts, we'll proceed with the next bit. Clear?
Yes, ma'am.
Okay. Next, proceed with the complement. Okay. So complement means if it is 0, it has to be converted into 1. If it is 1, it's just a not. Okay. If it is 1, so it has to be converted into a 0 there. This is what we call it as a complement. Right? So this is a number that is given to us. Okay. It is again 10 that is given to us. Okay. Take a complement of all the bits, individual bits. 1 is complemented, 0 is complemented to 1, 1 is complemented to 0, 0 is complemented to 1, 1 is complemented to 0, 0, 1, 0, 1, 0, 1, 0, 1, and so on till the last value. Is this okay?
Yes, ma'am.
Yes.
Yes,
Yes,
ma'am.
ma'am.
Okay. So this is what is the meaning of shift-wise operations. So you have variety of shift-wise operation. One is the AND operator. Okay. And you have the OR, you have XOR, you have the left shift, you have the right shift and a complement. Any doubt regarding these things? Any doubt regarding these things? Have any doubts?
No,
You
ma'am.
people can ask. Okay, so now if you have any doubts, you people can ask me. No issue in that. Right, so these are the things that I have mentioned. Okay, so now one more thing that I forgot to tell you. So that is what is the symbol that we are supposed to use. Okay, so this is a symbol that we usually use for the complement. Once complement, it is the symbol. It is called as tilt. Tilt. Okay. Is that okay? This is ampersand, pipe, cap. Okay. 2 lesser than, 2 greater than, and you have the tilt. So these are the symbols that we people use for the bitwise operators. So any doubt regarding these things?
No, ma'am.
Okay, then we'll go ahead with the assignment operators. Okay, so look at the assignment operator now. Okay, these are the variety of assignment operators supported by your C language. So normal equal to sign. If I write A equal to B, the meaning of this is whatever is contents of A that will be stored inside whatever contents of B that will be stored inside A. So if I take B is having something like 10 here, if I check A is equal to B, then if I check A, what is A, then it is 10 here. Okay, so it is an equal to our assignment statement. Okay. Next, you have something like this. So it is, the meaning of this is nothing but if I write A plus equal to B, what I have given here, this is nothing but, okay, this is associated with this and you can add this to this and result is finally stored back into this. So A is equal to A plus B can be shortly written as A plus equal to B. Is it clear?
Yes, ma'am.
Is it? Okay. So now if I write A minus B is equal to A, okay, but remember these two terms must be same to use these kind of operations. Okay, because sometimes you'll be writing x is equal to x plus 1. So in that case, these two terms are same. Then I can easily write x plus is equal to 1. The meaning of this is x is equal to x plus 1. Is that okay? That two terms must be same, then only you can play with that, otherwise you cannot play. If it is something like x is equal to a plus b, then you cannot adopt this. I cannot write x plus is equal to something like a plus b. This is not right. Okay, this is yielding me x is equal to x plus a plus b. Okay, that's what I'm not interested in. I'm interested in only single and the shorthand operation of the addition there. Okay, so this is true if the first two terms are same. X is equal to x plus a there. Then I'll be able to write x plus a is equal to, x plus is equal to a there. Is it clear?
Yes,
Is
ma'am.
that clear? Okay. So now similarly you have The same kind of operations are operators for the other things also. For the subtraction also you have, for the multiplication, for division, and for the remainder, that is modulus operation. How do I do? So this is the same thing. Look at this. So these two are same kind of thing. Okay, so if these two things are different, then don't use these operators. Okay, so I can write this as a slash equal to b. Okay, the meaning of that is a equal to a by b. Okay, this is also, that's what I have written. A modulus equal to b. Okay, if you become too much expert while writing the program, so you people can use this. Okay, but if you open the software written by the programmers or the software engineers, maximum times those people will be using these kind of shorthand operators there, or assignment operators there. Is that clear? So any doubt regarding these assignment operators, you people can ask me. I've given, okay, everything over here in front of you, everything is there. Still have any doubts, you people can ask me. Any doubt regarding the assignment operator?
No, ma'am.
Okay. You have to remember all these things. I'm not simply saying all these things. You have to keep all these things in your mind. Okay? Because if you open the previous year question paper, in maximum question paper, questions on the operator will be asked for not less than 10 marks till today. 8, maximum 10 marks. Okay. List out the operators found in C language, are used in C language. Explain all the operators with the suitable examples. You have to list all the operators and you have to give the example for all the operators to get the 10 marks for it. Clear?
Ma'am, can you give an example?
For what you want me to give example?
Second one, ma'am.
Pardon?
Second one, plus is equal to.
For this.
Yes, ma'am.
You take any example. Okay, so now if I write here, if I have something like A is equal to A plus C. Okay, for how do I write this? So I can write this if these two are same. If these two are same, okay, then I can proceed with this kind of things. If these two are different, then I cannot go ahead with usage of any one of these things. I already mentioned, if I have something like A is equal to B plus C, okay, in that case, I cannot write A plus B is equal to something like C here. This is not acceptable. This is not right. Okay, because these two operators are different. These two variables are different. Variables must be same. Then only I can go ahead with this kind of operators. Clear? Clear, student?
Yes, ma'am.
Okay, so now if I take, usually we go ahead with the incrementation of a particular number. Okay, so I have something like, let me take x is equal to 1. Then I wanted to get x is equal to 2. Then what I'll do? So I'll write x plus 1 is x plus equal to 1. So what is the value of x in this case? Any one of you?
1.
X is equal to 1. Okay. Now I have used operator. I have used this. Okay. This is my next statement.
2.
If I ask what is the value of x, x is
2.
2.
2.
Is that okay?
2.
Is that okay? Okay. So instead of this, if I write this as 2, what is the value of x?
3.
Is that okay to everybody?
Yes, ma'am.
Are you getting?
Yes, ma'am.
Okay. So now if I take one more example, x is equal to 4. Okay. Then I'll write x slash equal to 2. What is your expectation for x now?
2.
2.
Is it 2?
2.
Is it 2?
Yes, ma'am.
Is that okay to
Yes,
everybody
ma'am.
now? Right? Any doubts regarding this now? No. Still have any doubts? I'm in the same slide. You people can ask me before I proceed with. No doubts, I'll go ahead with the next one. Students, maximum students want to use these things, but if you want to be a part of a good, part of the good software engineers, you better have this kind of habits. Okay. This is my again suggestion.
Ma'am,
Okay.
ma'am,
Yeah.
for the modulus, ma'am, example.
modulus example you want? Okay, so now I
Yes, ma'am.
take, okay, so now I'll write x is equal to, so let me write x is equal to, x is equal to 5. Then I'll write x modulus is equal to 2. What is the value of x? X mod equal to 2.
1.
What is 1?
1.
That's all. That's all. Got no?
Yes, ma'am.
You got no? So the same thing, because you want to keep the remainder inside this. X is equal to x mod 2. Okay, x value is 5. 5 mod 2 is I am expecting a remainder of this. Okay, so 5 divided by 2 is yielding me remainder as 1. That 1 is placed inside the x. Clear?
Yes, ma'am.
Okay. Any doubts? Any doubts?
No, ma'am.
Okay. Shall we go ahead with the next operator?
Yes, ma'am.
They have two types of increment, operator there, increment and decrement. At least in maximum textbook, you'll see these kind of stuffs. Okay, so you have something called as incrementer and a decrementer operator. So this is plus plus, it is helping you to increment it by 1. So minus minus, it is helping you to decrement a particular variable by 1. Okay, so you have where exactly you are using this plus plus or minus minus, depending on that you have a name that is given for it. What is the name? Pre means you are using these things before. Post means you are using this after a variable. Okay, pre means before, post means after. You already know. Okay, because pre-primary, okay, and pre-education, you already know. Okay, because you already studied PUC and all those things, right? So now on that basis only, pre means before, post means after, right? Okay, so now I can use these operators before or after the variable. If I write a plus plus, okay, this is called as post increment. Okay, if I write this as plus plus a, then I call this as pre-increment. Okay, so similarly, if I go ahead with a minus minus, I call it as post-increment. Sorry, post-decrement. Minus minus a, so I call this as pre-decrement. Okay, whenever I say decrement or increment, by how many times it has to be decreased or increased? It is only by one value. Okay, if it is something like, if I take a is equal to, okay, maybe 5, if I write a plus plus here, okay, if I use like this, then if I check the value of a is 6. It is nothing but a is equal to a plus 1. So this is nothing but a is equal to a plus 1. Okay, so if I take again a is equal to 5 plus plus a, if I write, then again if I check for the value of a is also 6. Okay, this is called as pre-increment. Okay, and this is called as post-increment. Okay, and you may ask me, so both are giving us the same value, why it is pre-increment and post-increment? Correct, no?
Yes, ma'am.
Yes. Okay.
Yes, ma'am.
Nobody has asked. I'm only asking the questions and I'm only answering the questions. Right? Okay. So here, whenever you use these things inside the expression, so that time you'll get to know the importance of this. Till that time, it is as usual how you people are working on a is equal to a plus 1. Until if you don't use inside the, okay, what we call it as an expression. What is the meaning of that? Let me write one example. X is equal to, if I write, x is equal to a plus plus and something like plus 5. If I write like this. Okay, let me take a is equal to something like 4. Is it okay? Is this okay? Is this okay to everybody? Say something. A plus 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 5. Okay. So this is a plus. Let me write like this. Okay. Let me take a blank sheet and I'll try to explain that. Instead of this. Oh, it's black. Okay. So now look at this. So if I take x is equal to a plus plus, Okay. Okay, so I'm not supposed to write this. Okay, this is a plus plus only, then 5. Okay, simply write x is equal to a plus 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 5. Okay, just to bifurcate. This is post increment. Okay. Is that okay?
Yes, ma'am.
Okay, so let's take
Yes.
a is equal to some value, something like 4. So if I write here, okay, x is equal to, if I do this operation, okay, it takes this value. As usual, a is equal to 4, then 5 will be added to it and it is going to give me 9. Then if you check the value of a, you are going to get a value as 5, not as 4. I hope I am making it clear. Okay, post increment means the previous value of a will be used inside the expression, but after doing that particular, evaluating that particular expression, the value of this will be incremented. That's what is the meaning of post increment. Is that clear? So it is taking the previous, even though I have written it as a plus plus, it is not taking the incremented value of a. According to this a has to be incremented by 1, okay, because a plus plus is talking about incrementation of a. But it is not taking here a as 5, it is taking a as 4 itself. Then when a is incremented, after doing this evaluation, the a value will be incremented. This is what we call it as post incrementation. So I'll take one more example. X is equal to plus plus a plus 5. So what kind of operation is this?
Pre-increment.
Correct. It is pre-increment, right? Okay.
Pre-increment.
Again, I'll take it as a as 4 now. Correct. So now look at this. Now I'm going to take 5 plus 5 and I'm going to get this as 10. So now if you write like this, you are expecting output as 10. If you write like this and you are expecting x value as 9 here. Why it is so? Because it is mentioned here telling that before you use the value of a, you have to increment and you have to use that inside the expression. That's what it is suggesting. You increment before, pre-increment. You increment before, you work it, you take it, that value inside the expression. Clear? That is the difference between, okay, pre-incrementation and post-incrementation. I made it clear to everybody. Still have any doubt there? Because people have to be very careful whenever they use the pre-incrementation and the post-incrementation. You have to speak it out. Say something to me. Have you understood what I said? What do you mean by pre-increment? Okay, if it is used normally, so we don't find any use. I mean, it is normal a plus b. A is equal to a plus 1 only. But if you use it inside the expression, then only we'll understand the actual meaning of pre-increment or pre-decrement, post-increment or a post-decrement there. If it is used normally like a plus plus, you can use it as a plus plus. If you use it as a plus plus or plus plus a, doesn't matter. Both are same only. But if it is part of the expression, okay, if this is going to be part of the expression, then, okay, then it is going to take care of that. So it is first taking this value and evaluating this expression, then it is incrementing the value of a there. But if it is something like this, first it is incrementing the value of that particular variable, then the incremented value will be taken for the evaluation. Clear, student?
Yes, ma'am.
Still have any doubts? Please feel free to ask the questions. Any doubts, students?
No, ma'am.
Okay, so I think people can go further then. Okay. So these are the examples that I have quoted here. So now look into the example that's given. So plus plus, okay, this is pre-increment, I already mentioned, m is equal to 5. y is equal to plus plus m. If you check the contents of y, okay, and m, both are what is the value of y? What is value of y? 6. What is value of m? 6. Correct, no? Is it okay?
Yes, ma'am.
Okay, now look into post
Yes,
increment. Okay, m is equal to 5. Y is equal to m plus plus. What is the value of y?
5.
5.
Why 5?
Post.
Why?
Post
Y
increment.
is, it is post increment, correct? So whatever value y is, m is having presently, that value has to be placed inside this. So after assigning this value or after evaluation of this expression, the value of m will be incremented. That is what is the meaning of post increment. That's why if you look into this, so m is equal to 6 here, y is equal to 5 there. Is that okay?
Yes, ma'am.
Is it clear?
Yes, ma'am.
Okay. Okay. This is all about the pre-increment and the post-increment. And please remember, this must be carried out on single operation. Single operand. You cannot use two operands, right? Something like a plus b and all those things. So a pre-incrementer, post-incrementer, pre-decrementer, post-decrementer must be used on a single operand. Right? Unary operators. These are called unary operators. You are working on single operands. Okay. So this is another example for the minus. Okay, look at the minus, that is decrementation. So look at the m value. Okay, so I have written minus minus m. What kind of incrementation, decrementation is this? Pre or post?
Pre
Okay, so
decrement.
what is the value of y then? Y is equal to
4.
4.
4. M is equal to
4. 4.
okay. So go ahead with the post. Okay, so m is equal to 5. So y is equal to m minus minus. What is the value of y?
5.
5, because it is returning the same value. Then what is the value of m?
4.
4.
Then afterwards it is going to be decremented because it is a post decrement. Clear?
Yes, ma'am.
Is that clear?
Yes, ma'am.
Okay, so let's go ahead with the next thing. Okay. Okay. Some more examples are there. Okay, people can check it out. Okay, so now y is equal to x plus minus 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 k. Okay, x equal to 3, k is equal to 2 there. Now what is your expectation for this? Whatever answer I have written is the right answer. Here what is the value of x it is going to take here? 3 or 4?
Oh.
3.
3,
3.
because it is
3.
post. For this it is going to take, for this it is going to take
1. 1.
1, because it is
Pre-decrement.
pre-decrement, correct? Okay, then you add, subtract 1 from 3 because minus sign is there. So 3 minus 1 is
2.
2. So you got y is equal to 2. What about x value? X value is incremented by 1. Correct, no? X was 3. Now it is incremented by 1. Correct? Is it
Yes, ma'am.
okay? Okay. What about k? K is already decremented. I am going to keep the same value there. So k is equal to 1. It is pre-decrement. Is that clear? This is how exactly it is used inside the expressions. So again, it is post decrement. So post increment, post decrement. Okay, it is going to retain the same value. This is 3 and it is 2 only. So 3 minus 2, it is yielding me 1 there. But if you look at x and k value, so x will be 4 and k will be 1 there. Clear?
Yes, ma'am.
Yes, ma'am.
Right. So I have special operators. Okay. So what are the special operators that are available in C? If you look at these things, you have something called as the comma operator that is available. Okay, comma. Okay, whenever you write anything, usually we hardly use these kind of stuffs inside the programming part. Okay, but still this kind of stuffs are available in what we call it as the C language there. Okay, if you write like this, x equal to into bracket y is equal to 1 and z is equal to 2. Okay, in that case, the highest value of these two will be picked and that will be placed inside the x. Okay, this is comma means, so any one of these two value will be assigned usually. Okay, so now this expression, if you look at this, it's written over here. Okay, the value, the value, the value of the rightmost expression, okay, is assigned to the leftmost variable. Meaning is that, so it is going to be evaluated from right to left, not from left to right. Okay, that's why. So now it is going to assign this z value to this x rather than y value. Okay, this is usually what happens, but usually we'll not take care, use these things, but we will be using these things whenever we go ahead with the declaration section. So if I write here int, if I write x comma y comma z, something like this, maybe a, like this. So these are also separated by what we call it as a commas here. This is where we people use the commas inside our program. This is a special kind of operator that usually we use inside the programming there. So rather than these kind of things. Okay, because sometimes we forget that we have to evaluate from this, from the right to left. Okay, I'll be talking about that, but in the next classes, not now. Okay, evaluation of the expression I'll be dealing with, so that time I'll be talking. But if you want to remember, you remember whenever any comma operator is existing, it has to be operated from right to left, not from left to right. Because whenever you solve the expression, you start from the left side. Correct, no? Start the evaluation of the expression from left side, no? If I write x plus y plus z, something like this, what you'll do, first you'll take x term, then you'll be adding this to this, then again the result of this you'll be adding to this. Okay, this is how do you proceed. Okay, so left to right, scanning starts from left to right. Okay, but some of the operators that always be treated from right to left rather than left to right then. Okay, one of them is comma operator. And at least we use this for this kind of sake. And not only this, we have one more operator, I have not, I think, mentioned, and operator. Okay, so this and is separate from what and you people have studied as a bitwise operator there. So this and is called as the address operator. So this is, we are going to use this, but when to use this, I'll be talking about that once I begin with the second module there. Okay, but just remember, you have, this is one special operator that is available like comma. Okay, this is termed as and operator, or what we call it as address operator. Is that clear? Just remember. Okay, not, we don't use it right now. Okay, and this is not that and that I have taught you. Okay, so because that and is operated, whatever and I have taught you, bitwise and, if I write take here, so this and is not this and. Okay, because this and is unary operator. I'll write this as something like this. Okay, this is belonging to only this. Okay, this is belonging to both. Okay, we have to carry out the operation, bitwise operation on A and B. So these two operators are must for this bitwise and operator. For this ampersand B, if I write, this is belonging to only B and it is talking about the address of this B. Right? So this I'll be dealing once I begin with the second module there. So there I'll be discussing about that. Little, I mean, I'll just give a glimpse of that because in the fifth module, I need that. I'll give a glimpse of that. Clear?
Yes, ma'am.
Okay, so you have one more special operator called as size of operator. Okay, so now size of means, so you have something called you wanted to know. So what is how many bytes are reserved for that particular, the variable that I have declared. Okay, that at that time I was asking. So have you remember if I type it as int, okay, x. So how many byte is required for this? I said for integer it is 2 bytes. Correct. I said no. And for floating point it was 4 bytes. Did I say something like this?
Yes, ma'am.
Yes. So, but how do I remember this? For that, you people can go ahead with this size of. So you just give that, particular variable name. So you declare it as something like int x, and if you give size of x there, it's able to tell you how many bytes are reserved for this, whether it is a 2 byte, okay, and whether it is 4 bytes, whether it is 8 bytes, okay, that you will come to know by using size of. So let's look at this example. Float y is equal to 2.5. You don't worry about this because this is a data that is found inside that particular memory location. Y is 2.5. But how many bytes are reserved for this? Okay, so that is given by this. So this is 4 bytes. So this is different from this. Okay, this is a value, but this is talking about the size of that. How many memory location do you require to store this particular data floating point value? That's what is the size, meaning of size. So if you are not clear, you people can ask me. But if you don't ask, so I'll assume you have understood. Size of means how many bytes that are reserved by the system, compiler.
Yes, ma'am.
Okay, so now if I write double here, double, if I write x here, the meaning of this is, if you check size of x here, size of x, it is going to tell us 8 bytes. The meaning of this is 8 bytes, 8 memory locations are reserved just to store x value. This is what is the meaning of that. If I say it is only float, it is going to take it as 4 bytes. The meaning of that is 4 bytes, 4 memory locations are reserved to store the x value there. If I write it is int x there, then if I take the size of 2 byte, so how many locations?
2 locations.
2 locations, because we know that individual location is capable of storing how many bits?
8.
So 8 bit means? 8 bit means? How many bytes?
1 byte.
Very good.
1 byte.
This is 1 byte, this is 1 byte, so 2 bytes. So here 4 bytes means 4 memory location. 1 byte, second byte, third byte, fourth byte. 8 byte means 1 byte, 2 byte, 3 byte, 4 byte, and so on up to 8 bytes. This is how the things are going to change. I hope I made it clear. Okay, this is too much knowledge I have given to
Yes,
you all.
ma'am.
All right. Okay. So now these are the special operators. You have one more, I think, operator. I'll not be dealing it today. In the next class, I'll be taking that and I'll be working on the expressions in the next class. There are typecasting. Is that okay?
Yes, ma'am.
Okay. So be there only. So till I take attendance, or if you have any queries, you people can ask me. Okay. Have any queries, you people can ask me before I wind up. If you have any doubts, please feel free to ask the questions.